Alright guys, this is for pre-calc section 1.5. It's about showing you guys about inverses. Start out by taking this equation, and I'm going to evaluate it at -3. So you got the cube root -3 plus 1 over 2. So then you got the cube root -2 over 2. So that's the cube root of -1, which is -1. Take -1 and stick it in. And you guys can see you got the cube root of 0 over 2, which is the cube root of 0, which is 0. Take 15 and put it in. You get the cube root of 16 over 2, which is the cube root of 8, which you guys should have seen enough by now that hopefully seeing it as 2 is straightforward for you. Now I'm going to take those answers, those what are essentially y values, and put them in as the x values in this other equation and evaluate them in here. So 2 times -1 cubed minus 1. So it's 2 times -1 minus 1. So that would be -2 minus 1, so -3. Take 0 and put it in. So then you get -1. Take 2 and put it in. 2 times 2 cubed minus 1. 2 times 8 minus 1, 16 minus 1 is 15. Now at this point here, I'd love it if you guys saw it as you're multiplying, so I have the exponents. 2 to the 4th minus 1, sorry, the 4 looks like a 9. 2 to the 4th, it's close again. 2 to the 4th minus 1. Okay, 15. Point being, look at your x and y, and look at your x and y. They're switched. These are inverses of each other. Whatever I put into this equation and get an answer, this equation is going to undo what this equation did. They undo each other. They're inverses. To visually show you that, running with the idea, the theme that the x's and y's got switched, if you visually look at that, and this arrow is a little bit off, this is the 0.86. If I switch it and get 6, 8, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. Switch the points, 1, 2, 3, 1. That point can stay there. -3, -1, and then that'd be -6. 1, 2, 3, 4, 5, 6, 7, 8. If I were to graph this, and you have to give me a little patience here in getting this thing, because drawing with this slate is kind of, oh my god, that was awful. Oh, and I just erased the points. Okay. Ay, caramba. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 3, 1. 0, 0. -3, -1. 5, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Alright, let's try this again. This graph is the graph of its inverse. And interestingly enough, at least interesting enough to me, if you were to graph the line y equals x, it's smack dab right in between these. If you thought of this as a mirror and reflected it over the line y equals x, you get the other graph. When I do this in class, I have the kids actually graph these. Fold it on the line y equals x, and you get the reflection here, and you can see it just barely showing up in this. This is the reflection over that line y equals x. Now, what's so special about the line y equals x is that you're switching your x and y. So visually, graphically, you can see inverses by mentally flipping the graph, reflecting the graph over the line y equals x. It doesn't give you the equation, but it does give you the graph. Sticking with that idea, if I were to reflect this, these are the original two equations that I had up there, and if I reflect them over either one over the line y equals x, you can see that they're reflections, that this graph is going to, gravy is going to come over here, and this one is going to come along like this, if you reflected it over the line y equals x. Like, for example, this point that looks approximately 1, 0 is going to become 0, 1. Okay? That the x and y's get flipped, switched. So how do you find the equation of an inverse? Is, remember the good old days when this was just your y value? Y is equal to 9x minus 25. Switch your x and y's. X is equal to 9y squared minus 25. Now solve for y. You need to have x plus 25 is equal to 9y squared. Divide by 9. And you have x plus 25 over 9 is equal to y squared. Square root both sides. Don't forget to put the plus and the minus on there. And now I can split this into two separate fractions. X plus 25 over the square root of 9. And I can simplify the bottom. I can't simplify the top because I have addition going on. Over 3. That is your inverse. And we introduced a y that wasn't there before. There really isn't a y in the answer. And how you denote that it's the inverse of this is you write f, that's called prime. Oops, I'm thinking derivatives. I apologize. F negative 1 isn't like an exponent of x. So that's pronounced f inverse of x. It's not reciprocal. I know you guys know 2/3 to the negative 1 is 3/2. I know, but this means reciprocal when it's placed between the name of the function and the parenthesis. It denotes inverse, not reciprocal. So plus or minus square root x plus 25 over 3. And if you guys were to graph this, I graph the original and the inverse. So let's pick a different color pen. This is a parabola, 25 units down, and it's opening up. Okay? This one, it's a square root graph. Think of this as the value of a, it's a third. It's been kicked 25 units left. The plus gives you the upper half of the sideways parabola. The minus gives you the lower half of a sideways parabola. Now in both of these, pretend you're reflecting it, or in your mind's eye, see the reflection over the line y equals x. They give you each other. This graph would become this one. This one, if you reflected it, would become that one. They're inverses of each other. Okay, going for this one. Pretend you got a y. X minus 6. Whoops. X minus 6 plus 4. Switch your x and y. Subtract the 4. Square both sides. Sorry, I closed it. I apologize. I'm not sure what's going on with sometimes I close in my 4s. Add the 6 over. X minus 4 squared plus 6 is y. And then remember there's no y, so it's f inverse of x is equal to x minus 4 squared plus 6. Okay, now we gotta chat about these for a second. The original graph is a square root graph, and you guys know where it happens. 6 right, 4 up. 6 units right, 4 up. A is positive, so it's going to be the upper half of a sideways parabola. Okay? And if you were to reflect it over the line y equals x, the point 6, 4, that's a 4. I don't know why the 4's keep closing on me. Would become 4, 6 in the inverse. So 4 over 6 up. And I'm hoping that you'd see that this would be its inverse when you reflect it over it. So let's look at this equation down here now. It's a parabola, 4 right, 6 up, 4 right, 6 up. So it is starting where we predicted it would, but notice it's a parabola and it's both halves. And it's a heck of a parabola. Both halves, okay? So the original question was this. Its inverse should be that, so it should be just the right side. It should be just this piece over here. We can't allow this piece to be there. We have to restrict it. It's starting at the point 4, 6, and it's only good greater than 4. So this is the equation provided x is only greater than or equal to 4. You know this is a hard idea to get through, but when you solve them, you need to look at them and see, do I need to restrict the domain? We'll talk a lot more about this as we go. When can you expect to have to restrict the domain and when don't you have to? Okay, so I'll leave it with that. We'll talk more about this when you guys come in with questions off your homework.